Over the past few weeks of algebra, you have really upskilled, and so now you are ready to tackle one of the sections that combine some of these algebra concepts, and that is the section of algebraic fractions. Now, before we dive too deep into that section, let's have a look at what we remember from algebraic fractions in the past. So, having a look at example 1 here, we've got a over 9 multiplied by 27 over a cubed. So what we can do, because these are multiplying, we may cancel. As long as it's something in the denominator and something in the numerator, we are allowed to cancel that, or at least find something that goes into each. Okay, so what I can say here is that if I cancel this a, there'll be 1 left. And if I cancel here, I'll have an a squared. And then 9 goes into 9 once, and it goes into 27, 9, 18, 27, 3 times. Okay, so what am I left with? Now we multiply our numerators. So 1 times 3 is 3. And we multiply our denominators. 1 times a squared is a squared. So nice and simple, just a recap from the past, just to refresh your memory. Okay, then over here we've got x over 4 divided by x squared over 16. So in this instance, we can't start cancelling things. We need to deal with this division. So the way we've been taught to do that is to take this fraction that follows the division sign and we tip it over. So we write the reciprocal. That's the maths term for it. So we'll switch it and we'll call it 16 over x squared. And in order to do that, we need to change this then to a multiplication. So this is now going to become x over 4 multiplied by 16 over x squared. And now it is so similar to the one we've just solved. X can cancel with one of those x's. 4 goes into 4 once and into 16 4 times. And I multiply my numerators 1 times 4. I multiply my denominators 1 times x. And I end up with an answer of 4 over x. Now at grade 10 level, our fractions are going to look a little bit different. Okay. The biggest difference now between what we're looking at on this page and what we looked at on the previous page is that there are addition and subtraction signs in these. And what that means is that I'm dealing with 2 terms here and 2 terms here. And when that is the case, I need to factorize and then cancel. So it is so tempting to say that we want to simply cancel here and say x cancels with x and 2 cancels with 2. But we're not allowed to do that because those are separate terms. So instead, we need to factorize. Let's take a moment to just refresh our memory on the steps of factorization. Now, we've looked at this in a previous video, but it's always good to refresh our memory. Okay, so we always, no matter how many terms we're dealing with, we look for a common factor. Then once we've done that, we can tick it off the list and we can say, okay, how many terms am I dealing with? 2 terms, 3 terms, or 4 or more terms, okay? If I've got 2 terms, it is generally going to be either the difference of 2 squares, dots, or the sum or difference of 2 cubes. If I'm dealing with 3 terms, then generally we are going to be looking at factorizing a trinomial. And if we're looking at 4 or more terms, then generally we're going to be using grouping. So let's have a look at those examples from earlier and see how we can solve them using factorization. So what we're going to need to do is we're going to say, okay, well, what can I factorize here in my numerator? And what can I factorize here in my denominator? And once I've done that, only then may I cancel. Okay, the first thing that we always try and do with factorizing is take out a common factor of 2 in this case. Okay, I'm left with x plus 2 inside my bracket there. Over, and now I have a look at this denominator. X plus 2, there's no common factor. Then there's no difference of squares, there's no sum or difference of cubes. So that is then factorized as far as it possibly could go. Okay, but what we can remember from grade 8 to 9 is that a fraction like this technically puts invisible brackets around its numerator and around its denominator. So because that is fully factorized, I am allowed to then say, well, this is allowed to cancel with that. And this now simplifies to a beautiful answer of 2. Okay, here's another one. X squared plus 3x minus 28 over x squared minus 16. Okay, don't be tempted It looks so easy to cancel x squared and x squared, but it is not mathematically sound to do that. So because I straight away identify that I'm dealing with more than one term in my numerator, more than one term in my denominator, I know I need to factorize. Okay, I can't see a common factor here, but I will be able to factorize this trinomial. Okay, factors of 28, 1 times 28, 2 times 14, and 4 times 7. Okay, I can use that 4 and 7. So x and a 4, x and a 7. How can I use these to make a positive 3? Well, if I say positive 7 minus 4, that will give me plus 3. And then I just do a final check. Minus times a plus is a minus. 4 times 7 is 28. Okay, in my denominator, I don't see a common factor here. So I'm going to jump straight to my next option, which is the difference of two squares. And that is going to be the case. So I'm going to have two brackets. X times x gives me x squared. And 4 times 4 gives me 16. And 1 is positive and 1 is negative. And now I am ready to cancel what can be cancelled. So x minus 4, x minus 4. Okay. And that leaves me with x plus 7 over x plus 4. Okay, and now again, do not be tempted to cancel those. We've got more than one term, but there's no more factorizing to be done. So that is our final answer. Here's a nice big one for us to test our skills on. X squared plus 4x minus 45 over x squared minus 25 divided by x squared minus 5x plus 25 over x cubed plus 125. Okay, we're going to need to factorize this because the minute we see plus and minus signs, we know that we can't just cancel. And another thing that I hope you've noticed is that this is a division question. So we also are going to tip this and times instead. Okay, so we've got a couple of things coming our way. Let's do the tip and times first, and then we'll tackle this question. All right, so we can factorize now. We look for a common factor. If we don't find one, we can jump straight into what seems logical, which is going to be the difference of two squares. So we're going to need factors of 45 that can create a 4. Okay, and that to me looks like a 9 and a 5 could do that. So let's factorize this trinomial here. So we're going to have a bracket x and a 9, a bracket x and a 5. And how can I use a 9 and a 5 to make a positive 4? Well, that's going to be positive 9 minus 5. Okay, and then we do our sign check. Plus times minus is minus. 9 times 5 is 45. So that's great. Okay, denominator, x squared minus 25. Are there any like terms? And there aren't. So I'm not going to be able to group those together. Is there any common factor? There's no common factor. So I go to two terms, and that makes me think of the difference of two squares. So x times x is x squared, and 5 times 5 is 25, and 1 is positive and 1 is negative. So already this is looking so promising. Okay, let's carry on. On this side of the multiplication sign now, I've got x cubed plus 125. Okay, no common factor here. It's two terms, and there's a cube here. So this is x times x times x. And this side, I notice, is also 5 times 5 times 5. So that is going to end up being the sum of two cubes. Okay, so how did we do that? We said the cube root of the first term, keep the sign the same, and then the cube root of the second term. So that made our first bracket. And then we used that first bracket to help us figure out the next bracket. So we said x times itself gives us x squared, and that was the first term. Then we said multiply them together and change the sign. So that's going to become minus 5x for the middle term. And then finally, square the last term. 5 times 5 is 25. Okay, and then in the denominator, let's have a look. That looks like a trinomial to me, but do you notice that it is so similar to what I've just got here? Okay, so we can look quickly at the factors. We've got 1 times 25, and we've got 5 times 5 here as our options. Okay, and neither of these factor pairs is going to help me get a minus 5. Okay, I'm either going to get 0 or 10, or I'm going to get 26 or 24 here, just quickly looking at those factor pairs. So I am okay with leaving it exactly as it is because it matches so perfectly to that term written there that I've just factorized in my denominator. Okay, and I'm going to apply the fact that seeing as though it's a denominator, it can count together. We can put it in brackets there, and now I am so ready to cancel what can be cancelled. So x minus 5 can cancel with x minus 5. Then this x plus 5 can cancel with x plus 5. And this trinomial here, which I couldn't factorize, can cancel with that trinomial there. So we are left now within our numerator an x plus 9. And in our denominator, seeing as though everything's cancelled, it's technically just a denominator of 1. And we don't really need to write over 1. So that is our final answer. Okay, have a look at this. X plus 3 over x plus x plus 3 over 4. The difference now is we're no longer multiplying and dividing. We are now adding. And so in order to do that, I need to get a common denominator. So looking at the denominators I have, I've got an x and a 4. And between the two of them, I'm going to have to just make an algebraic denominator here of 4x. Okay, so this denominator needs to multiply by 4. And what I do to the bottom, I do to the top. And this denominator here needs to multiply by x. And what I do to the bottom, I do to the top. Okay, I like to write the thing I'm multiplying by in front of the bracket because it just helps me to apply that distributive law when the time comes. So 4 times x plus 3 plus x times x plus 3. And all of that is now over the same denominator of 4x. Okay, you are allowed to write it as a fraction over 4x and a fraction over 4x. But I find students make fewer sign mistakes here when they write one denominator. So that would be my advice, is that once you've made a common denominator, you can just write it once because they will all be over that same denominator. Okay, we're going to multiply the 4 into the bracket here, and when the time comes, we're going to multiply the x into that bracket there. So let's do that step by step. 4 times x, 4 times positive 3, x times x, x times positive 3. And that is all over 4x. And then I can just look for some like terms here. So 4x and 3x. And then 12 is a constant. X squared is its own term there. So we are then left with, it's always good to write in descending powers of x. So x squared plus 7x plus 12. And that is over the common denominator of 4x. Okay, so very important, grade 10s, is that you check what operation am I dealing with. If I'm multiplying and dividing, then I need to factorize and cancel. But if I'm adding and subtracting, I need a common denominator, and then I need to multiply in and simplify as far as I can. All right, next up, we have got a bit more complex denominators here to work with. Okay, y plus 2 and y minus 2. Now be very careful because these have already got pluses and minuses. They need to then be included. That's our entire denominator. So if I want to find a common denominator here, I actually am going to need to take the whole of this denominator and the whole of this denominator. So let's see what we would need to do. So the denominator is going to be y plus 2, y minus 2, both of those brackets. Okay, what you'll notice, let's color code this, is that the first one already had the blue and the second one already had the red. So basically the first one then is missing the red denominator, which was y minus 2, and the second one is missing this turquoise blue denominator, y plus 2. Okay, and that's just going to help us to stay on top of things. So y multiplied by y minus 2 minus 6 multiplied by y plus 2. Okay, we're going to distribute. So y squared minus 2y minus 6y minus 12. Lots of minuses there. over, you can multiply this if you want to. Do you recognize that this is the difference of two squares? Okay, so that's simply going to be y squared minus 4. Okay, look for like terms here. We have got like terms neatly grouped together for us there in the middle. So we can write this as y squared minus 8y minus 12 over y squared minus 4. Let's take a look at one last example. 3x minus 1 over x squared minus 5x plus 6 minus x over x minus 3 squared. Okay, I am going to need a common denominator. Why do I say that? Because these things, or this fraction here, is being subtracted from this fraction here. Okay, I'm also going to need to factorize in order to figure out what this common denominator is. Because I've got so many terms here, it's just so much easier once I've factorized to actually discover what is the common denominator. Okay, so I'm going to leave the 3x minus 1 because that doesn't appear to be factorizable, and generally we just tackle our denominators first. Okay, this denominator here, I don't see a common factor, and so I'm going to jump straight to trinomials. I've got options, either 2 times 3 or 6 times 1. This 6 option here often gives us options that will all work. Okay, so 2 times 3, if I say minus 2 minus 3, I can get a minus 5. But be careful. If I say minus 6 plus 1, I can also get a minus 5. So I need to now use my signs to help me decide. Okay, so we said minus 2 minus 3 or minus 6 plus 1. Okay, when I do a sign check, I want a positive overall. And so it's going to be minus times a minus is a plus. That helps me choose the 2 and the 3. Okay, so we've got here x minus 2, x minus 3. Minus x over x minus 3, x minus 3. I'm just writing it out twice. Okay, what have we got now? Let's color code. So we've got an x minus 2 that the second fraction doesn't have. So he's going to need to get one, x minus 2. Okay. Then we've got an x minus 3, which the second fraction does have. But be careful, the second fraction has actually got 2 x minus 3s. So that means we're going to need to include an x minus 3 here. Okay, and now we are ready to solve this big fraction. Okay, our common denominator, x minus 2, x minus 3 squared, and you can leave it like that. Okay, our numerator is going to be 3x minus 1 multiplied by x minus 3 minus x multiplied by x minus 2. All right. This is fine. This is something we can definitely do. We are going to use FOIL to sort out this double bracket here. So first, 3x times x, then outer, minus 9x, inner, minus 1x, finally last, plus 3. And then the next one is quite simple. We'll literally just multiply that minus x in there. So it's going to be minus x squared plus 2x. And that's all over this denominator here of x minus 2, x minus 3 squared. Let's group our like terms. So x squared goes with x squared, x's go with x's, and constants will stay together at the end. Okay, so we are left with 2x squared minus 8x plus 3 all over that common denominator there.